Hi, my name is Cassie Alphaby. I'm a junior at Iona College, and today we will be discussing Hooke's Law. So before we jump into the actual law, there's a few things you need to know. The first is about mathematical models. Mathematical models of physical events or situations allow one to predict the behavior of a system if certain parameters are supplied or established. Mathematical models give scientists equations in order to make calculations and predictions. For example, scientists use models to make short and long-term predictions about things such as weather patterns. The more a scientist uses the model, the more precise it becomes. A linear equation is a kind of mathematical model. A linear equation is an equation between two variables that gives a straight line when plotted on a graph. Now remember that I said it makes a straight line when plotted on a graph because it's going to be more important later once we get into Hooke's law. In Hooke's law, the mathematical model y equals mx plus b is used to record the behavior of a coiled spring when weight is applied to it. Y equals mx plus b is the most common kind of linear model. M equals the slope and b equals the y-intercept. When doing the Hooke's law experiment, x equals the independent variable, which is the length of the spring, y equals the dependent variable, which is the applied force to the spring, and the controlled variable in the experiment is the original length of the spring before it is stretched. In this experiment, the slope equals k and the y-intercept equals negative KLO. More specifically, the equation is applied force equals the slope of the line times the length of the spring minus length of the unstretched spring, or F equals KL minus KLO. You could predict the way the spring would react depending on this equation once you plug your data into the numbers. You could show this law on a graph, but by plotting the equation starting at the length of the unstretched spring, if done correctly, once you connect the plotted points, you will have a diagonal line going up. So remember I said it plotted a straight line if done correctly. So if you see here, the graph starts at the length of the unstretched spring, like I said, and once you plot the points, it makes a diagonal line, straight line. So that means you use if it looks like this, you use the equation correctly. Hooke's law states that a spring will be elongated a certain distance in which is proportional to the force applied to the spring. It says that if an object is within its elastic limits, the force required to stretch or compress an object is proportional to the distance that the object is stretched or compressed from its original length. Now, all of that just sounds like a lot of science from a textbook. So what does that actually mean? It means that when you have a spring and you add weight to it, it will stretch from its original length, but if you take the weight off, it'll go back to its normal form. In conclusion, Hooke's law is important because it shows the ability for an object to return to its normal shape after experiencing distortion. The perfect real-life example of this is a diving board. When you jump on a diving board, the springs expand and you go down, right? But if you jump into the pool, it goes back up into its normal shape. Another example of this is a balloon, the inflating of a balloon. If you blow air into a balloon, it expands. But if you don't tie the balloon, of course, and you let the air out, it'll go back to its normal shape. One more example is this elastic. So you can actually see how it works. When you stretch this elastic out, it looks like this. But if I let the force that I'm applying to the elastic go, it'll go back to the way it normally looks. So Hooke's law only works with elastic objects. So if I shatter a glass off the table and it falls to the ground, then I can't make it go back to its original form if I stop applying force to it. So I hope you learned something about Hooke's law today. Thank you.